Hi everyone, my name is Anthony.
I'm Dave.
And I'm Julia.
And we are excited to present Omnistream, a stream-based state management library for React. So managing asynchronicity, specifically asynchronous data flow within your applications, is very difficult. To put this into context, imagine you wanted to make a search bar and add, say, an autocomplete feature. How do you know that every time a user, when they're sending a click event, is going to receive the most updated search results?
Okay, so let's look at how we build this in JavaScript using promises. So our user presses the letter A, and that gets sent to our server to be processed. We expect the server to respond with a suggestion based on the character. But before it does, the user presses another button on the keyboard, and now there are two outgoing requests to the server. At this point, we have no way of knowing the order in which these results will return. So let's say our server responds with a suggestion of Atlanta. That's fine, but then on the third keystroke, our first request finally comes back late, and we're stuck with an outdated response. Because we're using promises, there's no way we could have canceled this irrelevant request at this point. So the problem we're trying to get to is, how do we deal with multiple asynchronous events? Using just callbacks and promises, it can get very difficult. But we think there's a great solution, which is to use RxJS observables. So this is a library that's maintained and used extensively by Netflix, and it's designed specifically for this kind of asynchronous programming. So an observable is really just a collection of events that arrive over time, which can be canceled or transformed any number of times, making them ideally suited to modeling multiple asynchronous events. The only problem is that in React, there is no state management library that's built around RxJS observables.
So our solution is Omnistream, an asynchronous first state management library built with RxJS observables and designed specifically for React applications. Omnistream includes a state management API, bindings for React, and some really cool dev tools.
All right, so David's going to walk us through a brief demo here, and there's two things we want to highlight. Number one, just give you guys an example of an asynchronous application built in Omnistream. And number two, demonstrate our nifty time travel debugger tool down here. So this is TweetStorm. It's connected to Twitter. You can type in any keyword here, and it'll return tweet data based on that keyword. Keep in mind there's an intentional bug here. So when we click this track tweets, ideally what we want to happen is the box to run immediately. But you'll notice there's a slight delay. Go ahead and click the box there. So you saw that there's a slight delay. If you scroll down to this time travel debugger tool and scroll through the lifecycle of the application, you'll notice that the box isn't rendering until it's receiving both the count and rate actions. Again, this was an intentional bug in our code, but we just wanted to display some of the usefulness of this debugger visualization. Also, one of the nice things about this app being built in Omnistream is that for whatever reason, if we were to lose connection to the server, just a single line of code adds that reconnect functionality. So as soon as we gain that connection, the app resumes. This would be a lot more difficult with promises. So now that we have like an overall view of the application, let's see how it's really working with it.
Okay, it all starts with the Omnistream, your single source of truth for state in your application. So the Omnistream is actually composed of several user-defined action streams, which, when combined with reducers, become state streams that hold the relevant pieces of state. The state streams pass down props to reactive components. Now this is an extension of the native React component class that we built specifically to be able to listen to the state streams. And then from the UI, users can dispatch actions, and these actions can take the form of individual objects or of observable streams, and this is really useful for helping out with that complex asynchronous behavior that we discussed earlier.
So thank you so much for your time. We're super excited about the future of RxJS development. Please check us out at the following links.